All right, so let's see what happens in here. And I said, the question is, imagine you are going to put this sequence in BLAST. You would give something much longer, but this is just to illustrate an example. And I want to know, would that sequence match this piece of DNA? So this is kind of review. What I wanted to see is there are two nucleotide sequences in here. What I wanted to see is, do you remember that you're supposed to read 5' to 3'? So if you remembered that, then you went like, okay, T, and then you went here, G, and then here there's an A, and then went the other side, T, A, G, C, G, T, T, C. So you'd get that sequence. That's one of them. And then I want to know what's the other sequence. And many of you might have done like, all right, I read this strand here. Let me read this one. I'm going, no, don't read this one. You're supposed to read the other DNA strand, but remember to follow the convention, right? So like, oh, this way. So wait, let's see. Yeah, this one. Then you would go A, C, G, go to the other side, C, T, A, this side, T, C, A. And I guess G. I might have skipped to the first C on the other, wait. Yeah, and then for the first sequence, I think I might have started here on the T, but there is starts with CT. Anyway, there should be 12. If you did 10 or 11, it's still okay. The point I'm trying to make is that when we give a sequence of DNA, BLAST will compare not only to, let's say that somebody entered this sequence here on the database. So BLAST will compare whatever you gave it not only to this strand here, but as you know, it will also reverse complement the strand that it has on the database so that it can compare to the other strand, which reads this way. So if you didn't understand the plus minus strand before, this is your chance. What we are asking is, does the sequence I enter match anything on this chunk of DNA? It doesn't matter if it matches this strand or this strand. So that's why BLAST has to do the reverse complement, and so then it will match your sequence to the reverse complement of one of these guys, right? So would the sequence from exercise 1, so that sequence is that. Would it match this one? Then you're supposed to go, no, let's see, C and T, that matches CT, but then G, A, T, whatever. No, this guy does not look like that. So you're supposed to say that does not match that. And then BLAST also does the reverse complement to see, okay, this sequence you gave me doesn't match this sequence that's what I have in the database. So I'm going to reverse complement this one, and then I'm going to compare your query sequence. Does it match the reverse complement with this, which is this? So if you didn't catch the answer as I was going up here, these are the two answers to question 1. And then you're supposed to say, okay, that and that don't look alike. No, they will not match. And then you go, that and that, even worse, doesn't even start the same way. So you're supposed to say, no, it doesn't match either. But you will be shocked to know that there is a way where they do match. And hopefully you're really scratching your heads now, like, how can that be? Let me tell you this, if I'm doing BLAST N, which is nucleotide to nucleotide, what BLAST is doing is taking my query sequence and comparing to the nucleotides. There'll be a bunch of these on the database, and it's comparing to all of them. And it's also reverse complementing everything that's in the database and taking my sequence. So here's the reverse complement. It's comparing to that. So when I do BLAST N, with these sequences, it would not find a match. But there is a way where these two sequences actually are a match. So if I translated this, then I would have a protein sequence. And then BLAST will take that sequence. So this guy translated. There are 6 possibilities here, as you will learn. That's what we call the 6-frame translation. So it will take each of those six possible protein sequences that come out of this and compare to a protein database. So let's see. When I said translate this in frame 1, I will introduce you to what you're going to do here. That will mean you have to look up something called genetic code. And you are going to see that 3 nucleotides encode 1 amino acid. So frame 1 means read the first, second, and third. That's 1 amino acid. And then the next triplet is your second amino acid. The next triplet is your third amino acid. And when I say do it in frame 2, what I mean is skip this first one, and these 3 are your first amino acid. So just as a visual on what that means, it's about time. Here's a game that I bought, and so down here, that is the mRNA that's going inside of this thing. The purple thing is a ribosome. I like to think it looks like a hamburger, but, well, no, the buns, and then that's the burger, or whatever, maybe that's a mushroom if you don't eat meat. But so here is your mRNA going in, and what's happening is for every 3 nucleotides encoded here, so there will be like 3 bases here, there is one of these red dots, that's the amino acid that is coming out. So they are completely different molecules, right? Biochemically, they are different. But the point here is that every 3 of these call for one of these. So you Google genetic code, and then you will have some idea of where this is going. Have a nice weekend. I'll see you on Monday.